All right, so here's the test review. All right, so it says to perform the indicated operation and to simplify. Okay, so first thing we'll do is number one, we're gonna factor these. So I'm gonna factor them if I need to show my work because I can't do it, then I will show my work. But difference of two squares, that's gonna be x plus 7 times x minus 7. X squared plus 14x plus 49 is x plus 7 squared, which is x plus 7 times x plus 7. Now we're going to factor the left side. This is going to be x plus 5, x minus 5. We'll do the x method here on this one. We have negative 15. We're dividing by a, which is 4, and then 4 times negative 25 is negative 100. Our factors are negative 20 and 5. So this reduces to negative 5. And this does not reduce, so we're going to bring the 4 in front. So 4x plus 5. All right, from here we'll extend our division bar. And we'll start from the top left and cross out 1 to 1, x plus 7 top and bottom. There is no x minus 7, x minus 5. So what's left here is going to be x minus 7 times 4x plus 5 on the top. And in our denominator is x plus 7 times x plus 5. And this will be our simplified answer. All right, let's take a look at the next one here. Same process, we're just going to factor and cancel. So this is going to be x plus 2 times x plus 1 over x plus 3, x plus 2. And we can definitely verify that. So 2, so let's see, x plus 2x, 3x, good. X squared, 2x plus 3x, 5x, 6, that's good. On this one here, x squared plus 7x plus 12, we can factor this to x plus 3 times x plus 4. And on the bottom, we have x plus 4 times x plus 1. All right, let's go ahead and extend our division bar and start canceling. We have x plus 2 top and bottom. We have x plus 1 top and bottom. We have x plus 3. And we have x plus 4. So we notice that everything is crossed out. So when that does happen, your remaining answer is going to be 1. Because anything divided by anything, it reduces to 1 if everything cancels. All right, let's take a look at number 3. X squared minus 9, that's a difference of two squares. This x squared, I can't really simplify it. I'm going to write it out twice just in case there's one at the top. Ooh, division bar. So when there's a division, we're going to multiply it, but this, we're going to flip it over. So this goes to the bottom, x squared plus x minus 12, which is going to be x plus 4 times x minus 3. And over here, I'll show you have to factor out the x first, leaving you with x squared plus 7x plus 12. So x times x plus 3, x plus 4. All right, and now this whole x times x, you can leave it as x squared. I just did it so if I cross something out, you can see it. So remember, it's division. You flip the second one over and you multiply. Okay, so we start from the top left. Do I see x plus 3 anywhere on the bottom? I don't. Do I see x minus 3? Yes, I do. Do I see an x? Yeah, I can cross out this x and this one. I can also, x plus 3 is not on the bottom. X plus 4 I can cross out. So on the top we see we have x plus 3 times x plus 3, or we can write x plus 3 squared. And all we have left on the bottom is a single x, so this is my simplified answer. X plus 3 squared divided by x. All right, for the next one, it's another division one, so we're going to flip the second one over, and then we're going to multiply. So let's start by factoring again. So x plus 5, x plus 4. Difference of two squares, x plus 2, x minus 2, times, so now we're going to flip this over, so this moves to the bottom, so it's going to be x plus 4, x minus 3. And here we'll do the x method to see this one. So negative 8 on the top, dividing by a, which is 3. 3 times 4 is 12, so it should be negative 6 and negative 2. Negative 6 minus 2 is negative 8. Negative 6 times negative 2 is positive 12. This can reduce to negative 2. And 3x minus 2. Extend our division bar and start from the top left, start crossing out. Nothing on the bottom, that's x plus 5. We do have x plus 4s. I do see x minus 2, but I don't see 3x minus 2. All right, so for this one, we have x plus 5 times 3x minus 2 in the numerator. In the denominator, x plus 2 times x minus 3. All right, for number 5, it says to add. So first thing we're going to do is we're going to find the LCD here. So let's go ahead and factor this out. This becomes x plus, let me see, x plus 9 times x plus 4. So in terms of our LCD, so let's see, what they have in common is x plus 9. What's not in common is this x plus 4. And now we just check to see what they need to make the denominators the same, right? So the second equation, I can see the denominator has x plus 9, x plus 4. It has both of them, so it has the LCD. Does not need to be multiplied by anything. But the first one, it has the x plus 9, we can see there, but it's missing the x plus 4. So we're going to multiply the top and the bottom by x plus 4. And this should allow you to see that now we have x plus 4, x plus 9, so we can combine these two. All right, so on the top, I'm going to distribute 5 times x is 5x, 5 times 4 is 20 over the LCD, plus x plus 4 over the LCD. From here, we can combine like terms. 5x plus 1x is 6x, 20 plus 4 is 24 over the LCD. Last step, I'm going to factor out the LCD, or the greatest common factor from the top, just to see if anything does cross out. So 6 is my GCF. 6 times x is 6x, and 6 times 4 is 24. Now instead of writing LCD, I'm actually going to write it x plus 9, x plus 4. And from here, we can see that the x plus 4s are common, so we're going to cross those out. And then my final answer is going to be 6 over x plus 9. All right, let's take a look at number 6 now. Okay, so before you even do this one, the first thing you should notice is you can actually reduce this 6 to 1 over xy. Okay, so in terms of your LCD, what do they have in common? Well, first off, we can see they have a y in common. They have an x in common. And that's it, right? So the 2 and the 3 are what's not in common. So 2 times 3 times x times y. So my GCF should be LCD should be 6xy. Okay, so from here, we're going to see what they need. So this one has 2x, and it needs to be multiplied by 3y. So we're going to multiply the numerator and denominator by 3y. The second one has xy, so it needs a 6. So we're going to multiply the top and the bottom by 6. And the last one, I'm going to change this minus to a plus sign, and this becomes negative 4. It has 3y, so it's missing 2x. All right, now we're going to multiply it. 3y times 5 is 15y. And the LCD is so small, just put 6xy. Plus 6 times 1 is 6. 6 times xy is 6xy, which is the LCD. Plus negative 4 times 2x is negative 8x over 6xy, which is the LCD. Now we see all our denominators are the same. And we really can't combine like terms here because they're all unlike terms. So I'm just going to put it in alphabetical order, so, or however you want, A, B. X comes before y, so I'm going to put negative 8x plus 15y plus 6. Any order does not matter because I just put it like this because it's the way it looked fine to me. If you wrote it as 15y plus 6 minus 8x, that's absolutely fine. All right, let's take a look at the next one here. Once again, we have a minus sign, so I'm going to change that to a plus, and the numbers on the top right, I'm going to flip them, so that becomes a minus 3. X squared minus 25 is a difference of two squares, x plus 5 times x minus 5. So in terms of the LCD here, we can see they have x plus 5 in common. And what's not in common is this x minus 5. So now the second one, we can see it as x plus 5, x minus 5. So the second one needs nothing, but the first one has x plus 5, but it's missing x minus 5. So we multiply the numerator and the denominator by x minus 5. From here, we're going to distribute the 2. 2 times x is 2x. 2 times negative 5 is minus 10 over the LCD, plus negative 3 over the LCD. And last, we combine like terms here. We can only combine negative 10 plus negative 3, so 2x minus 13. And we're going to change this to the actual LCD, and you'll notice that nothing actually cancels out. And this is your final answer. All right, let's take a look at number 8 now. So for number 8, once again, let's change this plus sign, this minus sign to a plus, and then we'll flip the top right signs. For the LCD, they have nothing in common. The x's are not in common because this is connected to the plus 3 and the plus 4 through the plus signs. So what's not in common is x plus 3 and x plus 4. So the first fraction needs the x plus 4 because it already has the x plus 3. The second one has the x plus 4, so it needs the x plus 3. So here we're going to distribute. 4 times x is 4x. 4 times positive 4 is 16 over the LCD. Plus negative 2 times x is negative 2x. Negative 2 times 3 is minus 6 over the LCD. Here we can combine like terms. 4x plus negative 2x is 2x. 16 plus negative 6 is 10 over the LCD. And last, I'm going to factor out this 2, leaving me with x plus 5. And now we'll see when we write the actual LCD if anything cancels out. And we don't have a 2 that we can simplify or an x plus 5 in the denominator, so this will be our final answer. All right, let's go ahead and move to the back. So for here, it says solve the following irrational equations. Show all your work. Give both the solution and the domain restrictions. Okay. So for the first one, to make it a fraction, I'm going to simply just put it over 1. Okay. Now for my LCD, they have nothing in common. What's not in common is x minus 3 and a 1, but I'm not going to write the 1, just the x minus 3. For the domain restriction, what can x not equal? Well, you can take your LCD, set that equal to 0 and solve, and you get x equals 3. That is the value that makes the denominator undefined. So right here, if you put in a 3, 3 minus 3 is 0, which makes it undefined. So therefore, x cannot equal 3. Okay. Now we're going to take the LCD and place it above each fraction. So pretty much we are multiplying to the numerator x minus 3. So we see if we can cross anything out, because that is the goal of this, to get rid of the denominator. So x minus 3 times 2 is 2 times x is 2x. 2 times negative 3 is minus 6 equals, here we see the x minus 3 is canceled because that's common on the top and the bottom, leaving us with x plus 2. Now at this point here, it's really up to you. I'm going to move 2 things at once. First, I'm going to subtract the x to the side of 2x to keep my x positive. And second, I'm going to add the 6 over so that the x is actually isolated. So 2x minus 1x is x. Negative 6 plus 6 cancels. Equals x minus x cancels. And then 2 plus 6 is 8. You always need to check this against the domain restriction. X cannot equal 3, so that means this answer is good. All right, let's try the next one. Once again, we're going to make this a fraction by putting these over 1. So for the LCD, what's in common is just this x. That's it. They have a 1 in common, but 1 times x is x, so we don't need it. The domain restriction, x cannot equal 0. So when you set this equal to 0, 0 makes these undefined. So now we're going to place the LCD and multiply it to each numerator on the top. So here, nothing cancels out, so 1 times x is x. Second one, the x's cancel actually, leaving with positive 6. Over here, once again, the x's cancel, leaving me with 2x minus 4. And then last, nothing cancels, so 3 times x is 3x. So let's combine our like terms. We have x plus 6 equals 2x plus 3x is 5x minus 4. Now for me, I like to keep my x's positive. It really doesn't matter. So I'm going to subtract the x from the 5x. And at the same time, to isolate x, I'm going to add 4 back to the other side. So x minus x does cancel. 6 plus 4 is 10. 5x minus 1x is 4x. And negative 4 plus 4 cancels. Last, let's go ahead and divide by 4. So 10 divided by 4 when you reduce it is 5 halves. We're going to check a restriction. X cannot equal 0. So this answer appears to be fine. X equals 5 halves. All right, for the next problem. LCD, since there are no numbers, I need to put a 1 under it. So negative 3 and x plus 2 are not in common. So my LCD is negative 3 times x plus 2. For my domain restriction, x cannot equal. So if you set this equal to 0, you divide by negative 3. 0 divided by negative 3 is 0. And then you subtract the 2. X cannot equal negative 2. At this point, you can cross multiply. You already know I'm going to put the LCD above and multiply to the numerator. And I'm going to cross out common factors. So here I cross out the negative 3. So I'm going to have to FOIL this out. X plus 2 times x minus 5. So x squared Negative 5x plus 2x is minus 3x and minus 10. Here I cross out the x plus 2, so 4 times negative 3 is negative 12. All right, since we have a quadratic function, what we're going to go ahead and do is we're going to move the negative 12, we're going to add it over to the 10. That way, so it's set equal to 0, and we can take our quadratic function and solve it. So if you were to factor this, you would get x, let's see, x plus 3, x minus 1. So verify that, x squared, negative x plus 3x. Let's see this. So it should be negative 2. Sorry about that. So let's verify this. X squared, negative x minus 2x is negative 3x, and negative 2 times negative 1 is positive 2. Okay, so we got that right now. So now we're going to solve it. So our two answers, x is equal to positive 2 and x is equal to positive 1. We check our restriction. X cannot equal negative 2, which means these two solutions are going to both be correct. All right, let's keep going here. Our next problem. Once again, I don't like these minus signs, so I'm going to switch it to a plus, and I'm going to flip the sign on the top right, which is because minus 2. All right, so let's go ahead and factor this. 4x squared minus 1 can become 2x plus 1. Sorry, erase that. 2x plus 1 times 2x minus 1. Okay, so the LCD, what do they have in common? So for my LCD, they in common, at least two have to have it. They have 2x plus 1, and then they also have 2x minus 1. Whichever order you write it in doesn't matter because you are multiplying. So now we multiply each numerator by this. So 2x plus 1 times 2x minus 1 for each numerator. All right, so the first one, we cross out the 2x minus 1. So x times 2x is 2x squared. X times 1 is x. For the second one, we can cross out 2x plus 1. Negative 2 times 2x is negative 4x. Negative 2 times negative 1 is positive 2. And then for the last one, everything cancels, leaving me with x squared plus 20. Okay, from here, I can't, oh, actually, we can combine x minus 4x. And last, it's a quadratic function, so we're going to subtract x squared over to the side, and we're also going to subtract 20 to the side as well. So 2x squared minus x squared is x squared, minus 3x. 2 minus 20 is negative 18 is equal to 0. This factors to x minus 6 times x plus 3. So my solutions are x equals 6 and x equals negative 3. One thing I forgot to do is the domain restriction. So x cannot equal positive or negative 1/2. And both answers are not positive or negative 1/2. So x equals 6 and x equals negative 3 are going to be my solutions. All right, let's take a look at the next problem. Draw a line through here so I don't get them mixed. All right, for the next one, LCD. So let's go ahead and factor this. This is going to factor to the GCF is x. It gives me x minus 2. So what do they have in common? So for my LCD, they have an x in common, and they have x minus 2 in common. So for my domain restriction, what can x not equal? Well, set this equal to 0, x cannot equal 2. Set this equal to 0, x cannot equal 0, and x cannot equal 2 when you set them equal to 0. And solve for x. All right, so let's go ahead and place the LCD above each one because we're multiplying to the numerator, and our goal, once again, is to remove the denominator. Okay, so the first one, I can cross out everything, leaving me with 10. For the second one, I can cross out the x, so 4 times x is 4x. 4 times negative 2 is minus 8. And the last one, I can cross out x minus 2, so 5 times x is 5x. All right, so let's go ahead and combine this. 10 minus 8 is 2, plus 4x equals 5x. We're going to subtract 4x to the other side, and that's going to give me 5x minus 4x is x, and 2. So x equals 2. Check our domain restriction. Oh, x cannot equal 2. So that's an extraneous solution. So what does that mean? Nothing's there. So my answer is no solution. That's why you always check the restriction to see if that solution exists or not. All right, and for the last problem here, we're going to go ahead and factor this. This is a difference of two squares, x plus 3, x minus 3. So for my LCD, what's in common, at least in two of them, is x plus 3. And what else in common is x minus 3. And there's my LCD. For my domain restrictions, x cannot equal positive or negative 3. All right, so we're going to place the LCD above each factor, multiplying it to the numerator. All right, for the first one, we're going to cross out x minus 3 because that's common on the top and the bottom. So 4 times x is 4x, and 4 times 3 is 12. So we're multiplying it to what's left over. Here we can cross out x plus 3. 2 times x is 2x. 2 times negative 3 is minus 6, equals, here everything cancels out, and we're left with 2x plus 2. So we can combine 4x plus 2x and get 6x. 12 minus 6 is positive 6. So here, again, we're going to move the 2x to the same side as 6x, and we're going to subtract 6 to help us isolate that x variable. So 6x minus 2x is 4x, 6 minus 6 cancels, 2x minus 2x cancels, so 2 minus 6 is negative 4. Our last step, we're going to divide by 4. X equals negative 1. Domain cannot be positive or negative 3. So your solution is x equals to negative 1. And now really quickly at the bottom, you have this little cheat sheet. It's how to simplify, multiply, divide, add, subtract, and solve rational expressions. So you do have those resources there. That's it.